Okay, so I just wanted to put up a little video of me going over a few of the questions that we went over today in class. I won't go over everything on this paper, but I'm just going to go through probably like the even numbers on this paper, and then I will pull up a compound inequalities, make a separate video for that, and I will do some problems there too. Okay, so basically, I'm just going to enlarge this so we can see a little bit better. Okay, so if we are doing any problem with inequalities, the main thing that you want to focus on is you want to kind of keep it separate from, hold on a second. You kind of want to like pretend that there's an imaginary line where that inequality sign is, and you want to essentially keep all the x terms on one side and the other terms on the other side. So right now I'm noticing that I have two like terms on the left-hand side here, a positive one and a negative one. So those would actually add up to 0 and cancel out. So now I'm left with 4x on the left and a negative 8 on the right. So in order for me to get that x completely alone, I'm going to divide by 4 on both sides. And so now I have x is greater than or equal to negative 2. Now, if your answer is set up so that your variable is on the left and your numerical answer is on the right, that's actually really good. You can have it set up the other way as well, but I think it's a lot easier to graph when it's set up this way. So the negative 2 is going to be marked on your number line, and you're going to want to fill in that circle. And the main reason you're filling in that circle is because of this little equal to line underneath. Anytime you see that equal to line underneath, that's when you're going to color in the circle, because x can not only be greater than negative 2, but it could also equal negative 2. So now we know that negative 2 is one of the numbers that x could be. X is greater than or equal to negative 2. All the numbers greater are over here on the right. And because we already had our inequality set up with the variable on the left and the constant on the right, if you look at the way this inequality is pointing, if you kind of imagine it being like a little arrow, it's pointing to the way you would shade. But I have to caution you that only works when the variable is on the left and the constant is on the right. So be very careful with that. It's easy to just not pay attention and then do it the opposite way. Okay, so moving on to number 4. Okay, so this time I have two like terms together on the right-hand side, the 5 and the 4. So now I have negative 6 is greater than 5n plus 9. So now I'm going to subtract my 9. So that gives me negative 15 is greater than 5n. And then I would want to divide to get that n all by itself. So now I have n is less than negative 3, or if you read it from left to right, you would say negative 3 is greater than n. Now, a lot of times people are like, okay, well, I'm going to do my open circle on the negative 3 because there's no equal to line, so it's going to be the open circle. But then when they go to shade, they shade to the right. But this problem, you have to be careful because you see our variable is on the wrong side if we leave our answer like that. So if I want to put my n on the left and my negative 3 on the right, so I can use that little arrow trick, I have to make sure that I write it in the correct order, which would be like that. So the variable has to come first if you're going to use that little arrow trick. Now notice here, my inequality is opening, so it's like eating the negative 3 and pointing to the n. It's still doing the same thing when I rewrite it in reverse, okay? So if you're going to flip-flop the n and the negative 3, you have to change the direction of the inequality sign as well. So now I know that n is less than negative 3, so that would go to the left, so it's going to go in this direction here. Okay, number 6. So I have two like terms on the same side of my inequality sign. So 2p minus 4p is actually negative 2p. And then on the other side, I have a negative 2. Now when I divide by negative 2, I'm going to have p, because negative 2 divided by negative 2 is just a 1. On this side, negative 2 divided by negative 2 is also a 1. But because we divided by a negative, we need to flip the inequality sign to face the other direction. So we have p is greater than or equal to 1. So since it's already set up the way we like with the variable on the left and the constant on the right, I'm going to do my closed circle at the 1. And p is greater than or equal to 1. So I know that all those numbers that are greater than 1 are to the right. Okay, number 8. Now, number 8, we have this -2 here, which is going to need to be distributed. Now, some people might want to write 3 minus 2 and change it to a 1, but you have to remember order of operations, otherwise known as PEMDAS. You have to do the parentheses first. So we have 3 minus 2n, because when we distribute a -2 to the n, we get -2n. Then -2 is going to get distributed to my -4, giving me a +8. And then I have my -1 over here. Now I have two like terms on the same side of my inequality. So 3 plus 8 would be 11. Now I can continue solving like I would a normal equation or inequality. So subtracting 11. So I have -2n is greater than -12. Dividing by -2. Now remember the trick, when you divide by a negative, you have to change the direction of the inequality sign. And negative divided by a negative would be a +6 there. So on my number line, it's going to be an open circle at the 6 because I do not have an equal to there. And n is less than 6. And since my variable's on the left, I can use that little arrow pointing trick. And I would shade to the left. Okay, number 10. Again, I'm going to distribute to get rid of these parentheses. So I will have -2b minus 2. And then I still have the +4 is less than 10. Now I have these two like terms that are on the same side of the equal sign. So -2 plus 4 is going to give me +2. And now I'm just going to continue solving. So subtracting 2 from both sides. 10 minus 2 is 8. Dividing by -2. Again, when we divide by the negative, we change the direction of the inequality sign. And 8 divided by -2 is -4. Plotting my -4 on the number line, it's going to be an open circle because I do not have an equal to line underneath. And b is greater than -4. All the numbers greater than -4 are -3, 2, 1, 0, and then all those positives, which would continue on here. And because my variable's on the left, I could use that little arrow pointing trick to figure out my number line graph as well. Okay, moving on to number 12. Again, we're distributing that 3. So I'm going to get 18b minus 3, and then that's going to be greater than 18 minus 3b. Okay, so now if I want to bring my variable over to the other side so that all my variables can be on the same side, so I'll have 21b. And then I'm going to add my 3 so that I can have all my constants on the opposite side. Just a normal way to solve an equation. Then I want to divide by 21, and I have b is greater than 1. So again, no equal to, so it's just an open circle. B is greater than 1. All the numbers greater than 1 are on the right. And if I use that arrow thing, since my variable's on the left and my constant is on the right, I can just look and see which way is that pointing. Okay, number 14. I'm going to have to distribute this -2 to get rid of those parentheses. So I have 20 minus 2p is greater than -2p minus 4 plus 4p. Now I have two like terms on the same side of the equal sign. So -2p plus 4p is going to give me +2p. And now I want to move all my variables to the same side. So I decided to move my p to the left, which is going to give me a -4p. And now I'm going to move my 20 over to the right. So I have -4p and then -24. And then I'm going to divide by -4 so that I can get my +6. And I have to change the direction of my inequality sign because I divided by a negative. So open circle at my 6. P is less than 6. less than numbers are to the left, and my inequality or my graph of my inequality would look like that. All right, a couple more. Okay, number 16. Change out my color so I don't blend here. Okay, so negative 6 times 1 is going to be negative 6. Negative 6 times 6x would be negative 36x is less than 6 minus 30x. So now I want to get all my x's together. So this time I'm going to bring my 36x over to the right. Last time I brought them to the left. This time I'll bring them to the right just so you can see the difference. So I have negative 6 is less than 6 plus 6x. Now I'm going to subtract this 6 and bring it over to the left. So I have negative 12 is less than 6x. Divide by 6. Now notice I'm dividing, but not by a negative, so I do not change my inequality sign direction. Now this time, I ended up with my variable on the right. But to graph it, I always find it easier to have my variable on the left. So if I want to put my x on the left and my negative 2 on the right, that's fine, but then I have to switch my inequality to face the other direction. Now I'm going to graph it. Open circle at the negative 2, and x is greater than negative 2, so that's going to go to the right. All right, number 18. I feel like, no, it's a little different. Okay. So I have negative 6 times 1, which is negative 6. Negative 6 times 2x, which is negative 12x. Then on the other side, 6 times 2 is 12x. And 6 times negative 1 is negative 6. Oh, and then we just have this plus 2x on the end. Two like terms on the right-hand side, so those can combine. 12x plus 2x would give me a 14x. And now I'm going to bring all my x's to one side. So you can either add the 12 or subtract the 14. It's up to you. I like bringing my x's over to the left with inequalities. That way the graphing part's just set up a little bit easier. However, then I'm going to have a negative I have to deal with. So there's pros and cons either way. So I have negative 6 minus 26x. And over here I just have a negative 6. Now I'm going to add my 6 to both sides. Now when I do that, I get negative 26x is greater than or equal to 0. So a lot of people kind of get confused when the numbers cancel out. If there's nothing left, you need to write the 0 as a placeholder. And now I'm going to divide by negative 26. So I have x is greater than or equal to, this would be 0. Now wait a second, 0 divided by anything is 0. However, I did divide by a negative, so this inequality sign does still need to switch directions. So I'm going to put a closed circle this time on my 0 because I have that equal to, and x is less than or equal to 0, so that would go to the left. Okay, and then my final problem for solving and graphing inequalities. Okay, so this one, be careful, there's a negative here, so this is kind of like distributing a negative 1, so be careful with that. So you're going to have 5x minus x, or you could write 1x if you want. Negative 1 times 2 would be negative 2. Then on the other side, we're distributing the negative 5, so we get negative 5 minus 5x plus 3. Now I have two like terms on the left, and then I have these two like terms on the right. So 5x minus 1x is 4x. And then on the other side, my negative 5 and my positive 3 is going to give me negative 2. And now I'm going to bring all my x's to one side. So I end up with 9x minus 2 is greater than or equal to negative 2. Then I'm going to add my 2. Now again, this happened in the last problem. When I add negative 2 and positive 2, they give me 0, but I can't just not write it because there's nothing left on that side, so I have to write the 0 there. So then the last thing I'm going to do is divide by 9, and x is greater than or equal to 0. Close circle on my 0. X is greater than or equal to, so it's going to go to the right. And that's what my number line graph is going to look like for that particular problem. All right. So it says here, name one particular solution to question number 20. So for example, any solution could be something in here. So it could be, X could equal 1, X could equal 2, X could equal 10,000, X could equal 0.1, anything that's greater than or equal to 0. X could also equal 0 for that matter. So those would be all examples of what X could equal.